Our next speaker is Greg McIntyre, AA5C. Greg has received his BSEE from Iowa State University and a master's from the University of Texas at Austin. He's a radar system design engineer and a registered professional engineer in the state of Texas. Greg retired from Raytheon, which was TI, in 2006 as a senior engineering fellow, and L3 Technology in 2017 as an engineering fellow. He's operational on all bands through 47 gigahertz and enjoys building, operating, and writing with articles published in QST and VHF, Central States VHF proceedings at Microwave Update. Greg was the 1998 recipient of the Central States VHF Society John T. Chambers Award. And please welcome Greg McIntyre.
Thanks. Which way do you go?
That's a big first step.
Yeah, it's interesting. Retired first time in 2006. And I thought, oh, now I'll get to work on all those projects. And then about 2008, stock market took a dive. So I retired again 2 years ago, 2017, and started looking around the shack and trying to get updated on a few things. Looking at some of the new modes and stuff, and started working WSJT, and found out, oh, we're back into teletype domain with the long duty cycles. And the 4CX250 amplifiers that I built in the mid-80s for VHF, UHF work didn't like those long duty cycles. And after I blew out the high voltage power supply because some insulation melted, I decided maybe it was time for what we used to call in work as a tech refresh. So part of that tech refresh was to put your head up. It seems like you get into this stuff and 20 years, 30 years goes by, and you've got your head down, everything you have seems to work fine. And then you put your head up and, oh, the world's changed while time has gone on. So what I'd like to talk briefly about are LDMOS devices and amplifiers, and that is in contrast to tubes. Tubes have been the mainstay for many, many years, but I think around 2000 or so, LDMOS started really taking on. It laterally diffused metal oxide semiconductors. They're enhancement mode FETs, which means you put a little positive bias on the gate to turn them on. And now they have drain voltages that are as high as 65 volts. That was always a problem with the 12-volt devices back in the 70s and 80s. You had to have so much current, the matching networks were hard to design, and now the voltages are getting way up there where it makes a lot of things easier. This is one of the devices. This is an Amplion BLF 188. That's a 1400 watt device, and up to 600 megahertz. They're now obsolete, but you can still find them new for less than $150. And compare that to some of the tubes that we used to think of. They're dual devices so that you can put them in push-pull operation, and the gain 20 to 28 dB. I'll talk about that a little bit more, but good gain on these devices. And their output VisWire performance is very robust. Now I put 65 to 1 here, but you have to take in mind there's the conditions for that. However, briefly, they would probably survive an open circuit or short circuit on the output, but very robust on the output. Okay, what's the Achilles heel? They're very sensitive to overvoltage or any glitches on the gate. So that's where you have to watch it. Again, compare to vacuum tubes. Okay, here's some of the devices. I just put this little table together, and what's interesting is you can get a lot of these at Mauser. A lot of the obsolete parts you can find on eBay. Some of them come from China, but a lot of them are Macom built parts, like the 151. But 50 volt drain supply, there's 65, 50, 50. This is one of the older parts. It's 26, but it is going up to 2 gigahertz. So 1.8 kilowatts on that particular part with 65 volt drain. This is real serious power. Manufacturers, Amplion, Macom, Qorvo, Infineon, ST Microelectronics, and seems like always have to have a scorecard to keep track of the mergers and buyouts and everything. For instance, Freescale and NXP merged, and then Amplion was a spin-off of NXP, and RFMD and TriQuint merged to form Qorvo. You just kind of have to keep the card there so you can keep track of it. Okay, so what are your options if you want to go down the LDMOS path? Surplus amps have been available from the transition we made from analog to digital TV. The ones I'm aware of are Larkin Amplifiers. They're a Canadian firm that built these decks that I'll talk more about, and Harris. I don't have much experience with the Harris amplifiers, but I've seen a lot of them offered for sale on surplus. Another way to go is you can build from available parts or sub-assemblies. I put W6PQL here. Many of you are probably familiar with his work. 2012, he had a real nice article in QST on a 1 kilowatt 2 meter LDMOS amplifier. And you can buy parts or subsystems or full custom systems from Jim. Noticed N4GA also has amplifiers available, or full commercial. I'm not as familiar with some of these, although I do have a Tokyo high power amp sitting on the desk for HF, which was full commercial. Or you can design and build your own. Build the input and output matching networks and all that goes with it. So runs the gamut. This is a Larkin low or low-high RF deck. These things are about this long, about this wide, and the whole bottom under here is heat sink. The top side, there's 2 circuit boards, an input board and an output board, devices here in the middle. There are 12 devices, 6 dual devices, 12 amplifiers on this board, each one 300 watts. The Larkin low covers 54 to 88, and you really do need to modify it to get it down to 50 megahertz, which is not bad to do. You can also go the other direction and go up to 144 megahertz with them. So to get this to 50 megahertz, I added or replaced 36 ATC caps on here, and that got it, came out to be a really, really nice amplifier. Up to 1500 watts, 20 dB a gain, and then you can see this little board back here, and that's where the startup and the bias circuitry is. Now you do have to do something about the connectors, input and output connectors, and make sure you add the cooling and sequencing, which I'll get to in a moment. This is the high band Larkin deck. This one covers 174 to 216 megahertz, and it works as is on 222 megahertz. Same thing, air-cooled, 6 dual devices, and this one's up to 1500 watts output. Gain's a little lower, and the efficiency is down a little bit. So my experience is this one takes quite a bit more cooling air. So I get the earplugs out when I want to run run it for a long time on a meteor scatter sked. Again, the bias and startup board is on the back here. Okay, so say you can find a Harris or Larkin RF deck. What do you need to do? First thing is build a sequencer. The venerable W5 LUA design with an LM324 works quite well in this. And sequence it going from receive to transmit. First switch in the TR relays, then the bias and startup, and then third, finally, apply the full drain voltage. And then to go from transmit to receive, just go through the reverse sequence. Cooling, 125 millimeter muffin fans work well. 4 of these along the bottom do a good job. Yes, Ken? Can you just leave the bias on? Might be able to. I haven't tried it that way. For the connectors, these amplifiers were designed to be hot plugged into a rack. So it's really interesting. It's a very simple design, but it's quite efficient. They have a long pin for 50 volts that is the startup circuit, and then the shorter pin is the full power circuit here. That's what you simulate with the sequencer. And when you bring them up, crank the biasing down so that none of the devices are conducting, and then bring them up gradually. Make sure you add your input and output relays for switching or whatever you're going to do there. And then on the input side, this is where you really need to pay some attention. Make sure that you're not going over the maximum input level on these devices. Start out cautious, and whatever value of attenuator there is going to depend on your rig. Another thing I'll talk about is you've got to make sure that your rigs don't glitch the input of the amplifier, because that could take them out as well. Okay, power supplies. How many are familiar with the HP EPS 120? What people are familiar with them? That's this big brick back here, this long brick. It's a great power supply. It's a little awkward because it's so long, but they're cheap, and they put out 50 volts and 60 amps, so it's pretty nice. 220 volt input, 20 amp, and what I did, as you can see here, is just mounted the amplifier on a sheet of 1/8 inch aluminum, and then I added in all of the switches, terminal strips, and a 24 and 12 volt supplies to handle all the auxiliary stuff that I added. Terminal strip on the back. That's the ESP120. Recently I found another supply, this LTEC 48V/3000, which is actually a little smaller format. It's a little awkward to use because it's a plug-in, and it plugs into a circuit board, printed circuit board on the back. But what I found is you can take a little circuit board, piece of raw circuit board, FR4 with copper on it, and if you use the cut and peel technique, you can peel off the parts you don't need and make a good connector that slides right into the back. Right, mentioned those and mentioned those. Got to have good ventilation. I don't necessarily. Right here, there's a gap, and sometimes when they get a little noisy because the fan speed kicks up, I'll just pull the tray out a little bit from the rack, and that gives it enough air. Okay, so my version of a tech refresh was to get rid of the 4CX250, 4X150 amps I had on 6 meters, 2 meters, 222, and 432. And I went with a whole, just gutted the rack, and build everything up from scratch. So here, there's a 222 megahertz Larkin, 1.5 kilowatt solid state rack, a power supply tray, and another Larkin, 50 megahertz amp, 1.5 kilowatt. And this power supply feeds both of these amplifiers. And then I make sure through the enables that I don't ever turn both of them on at the same time. Also have an enable switch on each amplifier. For 2 meters and 432, I went a little bit different approach. This is a W6 PQL amp that Jim built up for me. And it's seen lots of service and 2-meter moon bounce and performs quite well. The 432 amplifier, I bought the RF deck from Jim and some of the other parts, and then I spent a lot of time with a file and made a panel so it looks just like the 2-meter amplifier here. One power supply tray feeds both of those two amplifiers. And again, I use the control wiring to make sure I never turn both of them on at the same time. So for microwaves, this is a 600 watt 1296 amp. Well, it's the RF deck that Jim sells. And 600 watts, 10 watts drive. Looks like a pretty nice setup for moon bounce. I don't have one yet, but I'm seriously thinking about getting one. Okay, so now that I put my head up, looked around a little bit, I think the LDMOS technology is rapidly overtaking vacuum tubes. It'll be a mainstay technology for amateur high power amps in the future. There are a lot of approaches you can take to getting an LDMOS amplifier on the air and design from scratch. These surplus RF decks, parts and assemblies are full turnkey. And then the thing you got to watch out for is make sure you protect that gate. Don't ever let it get away from you. From glitches, well, you got to make sure your driver doesn't glitch. And if it does glitch, then you've got to put enough attenuation in there to make sure that that glitch isn't enough to damage the input. It's a balancing act. But no AGC or ALC is fast enough to protect them. So you have to do it on the input. I was converting a AML amplifier to 2304 from 1900 megahertz, and I put in a pot to set the bias, and you see this nice blue flash under the beryllium on top, and you know, well, that one's torched. And I torched the second one, and I started, well, time to get the oscilloscope out. And I put it on the pot, and the darn pot was noisy, and that was enough to take out the FET. So be careful. If there's any place that'll go bad, that's probably there. But as I showed, the output very rugged. I think they use a lot of these in plasma heating. Continue to look for the technology to advance. We're continuing to see the drain voltage go up, higher power. One device I showed was an 1800 watt device, dual device, and frequencies are going to go up. So I think this is what we're going to be seeing more of in the future. That is all I have. Questions? One here. 432, I can get a kilowatt out of it. I can get a kilowatt out of it. It's going into compression, but I can get a kilowatt out of it. Barry?
I wondered on your Larkin amplifier, how you mounted that. Is that a 19-inch rack, a 24-inch rack?
Okay, let's go back a little bit here. Okay, it's a 19-inch rack, and I took off the front panel of the Larkin deck, and all of the sequencer and bias circuitry is on a plate, 1/8-inch piece of aluminum on the bottom, and then I put risers on it to get the amplifier deck up. And on the underside of the amplifier where the heat sinks are, I used aluminum angle and mounted 4 fans along the bottom side of it. So sequencer, control circuitry, RF deck, the heat sink is here, and the fans underneath there. It's 22 inches long. It's a long deck. Well, same problem with the power supplies, the ESP120s. Another question? Say again, please. Okay, on the Larkins, basically you can take the gain and back off to determine what the full input power is going to be. 10 watts will get me more than enough on the Larkin. Now, because it's got 20 dB gain. The 222 amp is a little less. It's 16 dB gain, so we'll have to drive it a little harder. Another thing I should mention on like the PQL amps, Jim builds a little attenuator, so you can get 0, 6 dB, 12 dB type attenuators and put in whatever you need for your driver. It can, yes. You just have to look at the gain and back off so you know what level is your maximum input level, and make sure you never exceed it. Yeah, the glitches are what I understand to be the problems too. Question? Sir, did you hear his answer? He knows a fellow in the UK that is building a board. It's basically a limiter. That's what we always put on the front end of a radar receiver, was a limiter to make sure the transmitter didn't kill it. And that's what he's talking about. Right. Right. Good. There's one other question. Okay, that's all I had. Thank you.